Let's consider the next one. If the point 2 alpha beta lies on the plane which passes through the two given points and perpendicular to a given plane, then we have to talk about 2 alpha minus 3 beta. So let's start this question. Can we write the equation of this plane? Yes, we can write the plane as it is passing through 2 points and is perpendicular to this plane. Since the plane is perpendicular to this plane, so obviously normal of the required plane is perpendicular to the normal of the given plane. So the given plane is simply x minus 3, y minus 4, z minus 2. Next, find x2 minus x1, y2 minus y1, z2 minus z1. That gives you 4, minus 4 and 4. Lastly, you have 2, minus 5 and 0 is equal to 0. So this is the required plane. Now simplifying, you can say take 4 common and put it on the other side. So second row becomes simply 1 minus 1 and 1, correct. On simplification you get x minus 3 multiplied with minus 1 into 0 plus 1 into 5. So you have the term simply 5. Next, y minus 4 is multiplied with this one minus 2. So this becomes plus 2. Moving ahead, next is z minus 2. This is multiplied with minus 5 plus 2, that is minus 3, is equal to 0. Simplifying, your plane is 5x plus 2y minus 3z and the constant is minus 15 minus 8, that is minus 23 plus 6. So it is minus 17 equals 0. So the required plane is 5x plus 2y minus 3z minus 17. Now 2 comma alpha comma beta is lying on this plane. Put 2 alpha beta. 2 alpha beta. On substituting it here, you get 2 alpha minus 3 beta is equal to, when you put here 2, it becomes 10 minus 17. So you can write here 7. 2 alpha minus 3 beta equals 7. Let's see from the given options. 2 alpha minus 3 beta equals 7. That is option number 4 is the correct answer. Let's move on to the next one, that is question number 26. All x satisfying the inequality, one quadratic inequality, if you say cot inverse x is t, so you can say quadratic in t is given. Now this can be simply factorized as cot inverse x minus 2 into cot inverse x minus 5 greater than 0. From here you have cot inverse x lying in the interval minus infinity to 2 union 5 to infinity. Now we already know, we can say, but cot inverse x actually lie between 0 to pi. So from here my conclusion is simply cot inverse x is lying in the interval 0 to 2. You can read it as cot inverse x is greater than 0 but less than 2. Since cot inverse function is decreasing, so you can say here x is lying between cot 2 to infinity. So the result is cot 2 to infinity. Let's see from the given options, cot 2 to infinity is option number 1. So let's mark and mention it as the correct answer. Moving on to the next one, that is question number 27. Let root 3 I plus j, I plus root 3 j and beta I plus 1 minus beta j. So we have 3 vectors in simply xy plane, there is nothing like z. Be respectively position vectors of ABC with respect to origin if the distance of C from bisector of acute angle between OA and OB is 3 by root 2. So let's first locate where these points are actually in Cartesian system. So let's draw the Cartesian plane x, y. Right. Now first one is root 3 comma 1, second is 1 comma root 3. So just mark here root 3 comma 1 say here and 1 comma root 3 say here, right. When you talk about these 2 points, can you see the fact it is inclined at 30 degree and this one is inclined at 60 degree. So angle bisector is clearly angle making 45 degree. So this 45 degree meaning you have the line equation as y equals x. Now next part is there is a point C, right? Point C whose coordinates are beta comma 1 minus beta, it is at a distance of 3 by root 2. So drop perpendicular from beta comma 1 minus beta on the line. So beta minus 1 minus beta whole divided by root 2 modulus is equal to 3 by root 2. So from here we have simply 2 beta minus 1 is plus minus 3, right? Taking plus sign we have 2 beta is equal to 4 or beta is equal to 2. Taking minus sign you have 2 beta is equal to minus 2 or beta is equal to minus 1. Since the question says sum of the values of beta, that means sum the two values, that is 2 plus minus 1, giving you the final result as 1. So correct answer for this question is option number 2. Let's move on to the next question, that is question number 28. Let's move on to the next question of this paper, that is question number 28. Differential equation is there, dy by dx equals x minus y whole square. We have to find the solution of it and one initial value condition is given as y1 equals 1. So let's say x minus y equals t. That means you have 1 minus dy by dx is equal to dt by dx. Now dy by dx is given to me x minus y whole square. So we have 1 minus t square is equal to dt by dx. Just integrate after cross multiplying dx on the one side and 1 minus t square on the other. We have x is equal to 1 by 2 log modulus of 1 plus t upon 1 minus t plus constant of integration. y1 is 1. So you have x and y both 1. When you substitute, what is the value of t? When x is 1, y is 1, you can see t becomes 0, right? So substitute here, 1 is equal to half into 0 plus c, giving you the value of c as 1. Once you obtain the value for c as 1, you have the solution as x minus 1, taking c on this side, is equal to 2 can also be multiplied log modulus of 1 plus x minus y upon 1 minus x plus y. Let's see from the given options. 2 times x minus 1 is given here in just one option 3. Let's see what is given with log. Log 1 plus x minus y upon 1 minus x plus y. If you look at this term, it is minus. So on taking reciprocal, it is 1 plus x minus y upon 1 minus x plus y. So correct answer for this question is option number 3. I'm sure this part is clear how we simplify this differential equation. Let's move on to the next one, that is question number 29. Let k be the set of all real values of x where this function is not differentiable. Now there are two terms involved, 0 and pi in the option. If you look at it, sine mod x, only 0 is the crucial point, pi it is clearly differentiable, right? So let's redefine the function about 0. We have fx is equal to minus sine x plus x plus 2 times x minus pi when x is less than 0. On the other hand, it is sine x minus x plus 2 times x minus pi when x is greater than or equal to 0. Let's differentiate on each side excluding the endpoint. We get minus cos x plus 1 plus 2. Here we have cos x minus 1 plus 2 when x is less than 0 and when x is greater than 0. When you approach towards 0 from the left hand side, that is f dash 0 minus. What's the result? You can see 2 plus 1 minus 1. So that gives you 2. When you approach towards 0 from the right side, you can see 2 minus 1 plus 1. That is also same as 2. So clearly the function is differentiable at 0 as well. So function is differentiable everywhere, meaning K is an empty set. So the correct answer for this question is option number 2.